Now let us go to this problem number 2. If the radius of Earth it shrinks by 2%, the mass remaining constant, how would the value of acceleration due to gravity change? Now here we have to find the change in acceleration due to gravity with a change in radius. So if the radius changes, how would it affect acceleration due to gravity? It will definitely change, right? Because my formula for G is equal to Gm upon r square. So if this is changing, this will change. Okay, so let us try and find this out. My initial radius is r, correct, and my final radius after the radius decreases by 2%, that means my r1 is equal to r and r2 is equal to 2% reduction, so it would be 0.98 r, correct. So let us have this in mind, but before going with this method, let us see if we can do something else. Okay, now what I'm going to do is I'm going to use a little bit of calculus here. I'll be taking log of both the sides. So log of G is equal to log of Gm upon r square, right? Now here it would be equal to, so now it is log of a quotient, so log of numerator minus log of denominator, but then log of numerator if I take, it is again log of a product, so this is going to be log of G plus log of M, correct, plus log of or it would be minus log of 1 upon minus log of r square, and then this is your log of G. Okay, now if you see this log of G and log of M, my G is constant, it is universal gravitational constant. Mass of Earth, it is constant. They have said here the mass is remaining constant. So if I differentiate both the sides, differentiating log of G, so derivative of that would be 1 upon G into dg. Now dg is increment or change in G, and this is a constant, so derivative of constant is 0, derivative of this constant is also 0, and derivative of this, it would be minus 2 into derivative of log of r, so that would be 1 upon r dr, right? So my dg upon G is equal to minus 2 dr upon r, correct. Now what is dr upon r? Dr upon r is change in r upon r, so actually that is that fraction, if you multiply it by 100, so you multiply by 100 on both the sides, so that would be dg upon G into 100 is equal to minus 2 dr upon r, correct, into 100. So my dg upon G, now here my radius is decreasing by 2%, so it is minus 2 into minus 2 upon 100, correct, and that multiplied by 100 here, so that would be 4%. So percent change in acceleration due to gravity here is going to be 4%, right? So I'm going to write the answer here. Therefore percent change in acceleration due to gravity is equal to 4%. Now here one thing is worth noticing, that I have taken dr upon r as minus 2 upon 100, isn't it? So minus 2 upon 100 is what? So minus 2 upon 100 into minus 2. So that is giving me 4%. So if my radius decreases, my acceleration due to gravity increases. It is quite clear from our initial formula here. If my quantity in the denominator is decreasing, my quantity, the whole quantity is going to, the quotient is going to increase. So that is what we got over here, and this method looks pretty simple. But then can we use this and get the same results? Let us check if we can get it. My G is Gm upon R square, correct? So I would say G1 is equal to Gm upon R1 square. And what about my G2? My G2 would be Gm upon R2 square. Now let us take ratio of the two. So G2 upon G1, or shall we take G1 upon G2? I think we have to find what happens to the acceleration due to gravity. So let us take the final acceleration upon initial acceleration. So G2 upon G1 is equal to Gm upon R2 square divided by Gm upon R1 square, right? Now my Gm and Gm, they are going to get cancelled. So it is going to be R1 square upon R2 square, right? So now what is my R2? R2 is 0.98 times R1, correct? Therefore G2 upon G1 is equal to R1 square upon my R2 is 0.98 R1 whole square, and that will be equal to R1 square upon 0.98 R1 square. So then 0.98 square, it will be R1 square, correct? So my R1 square and R1 square are going to get cancelled. So this is going to be 1 upon 0.98 square, correct? So this is going to be 100 into 100 upon 98 into 98. And this is going to be approximately equal to 0.9604. Right? So my acceleration due to gravity is going to be my initial acceleration multiplied by 0.9604. So I would write G1 into 0.96. So now here, can you make out, isn't the change 4% of my initial value, right? Therefore we can say G2 changes by 4%, and that matches with what we did earlier, correct? So that is how the acceleration due to gravity changes with change in radius. In the next videos, again we are going to do few more problems. Thank you so much.